In this lecture, we are going to go over your assignment in decision tree. So please log into your decision tree folder, and under the decision trees assignment, you should see the data set and some guideline about what you are going to do in this assignment, and finally a location where you're going to upload your Word document as a solution for this assignment. You have two data sets. One data set is the counterparty risk data, and the other one predict default. Let us open the first data in Excel. In this data, you might have guessed it from the title of those two data sets. So this data set is about a bank that has some loaners and their status of their payments, if they defaulted or not. So this is our label here. So our label is yes or no. If each one of those customers based on multiple types of attributes over here. So we have, for example, long-term financing of working capital, some other aspects that were collected about those customers. So as you can see, we have plenty of information about their return on equity, for example, fixed asset to debt ratio, short-term debt to sales ratio, expense to revenue ratio, fixed asset turnover, collateral, and the firm size as well. Okay, so we have enough information about each customer, and as you might have guessed it, the idea is based on this information we have and based on the trend that we can see in the attributes that we have collected in those customers, from these customers, we are trying to create a predictive model that will model the customer's type. So based on some trends the model can find from these informations, is going to create a decision tree for us in which if the customer defaulted with a value of yes, he or she might have some type of patterns in the associated attributes, and if he or she did not default, again might have some other type of trends in their attributes. So pay attention to this data, because if you open it in RapidMiner, you will get an error after you start building a model. And the reason for that as you can see here, we have part of the data that has the label is missing. We talked about decision tree that is really a flexible model that can handle missing data. But pay attention here, missing data for the independent variables, anything but your response value or the label that you want to predict. So there is no way that you can create a model where your Y is missing. So you have first to delete those records from the data and to consider only those 390 customers in this data. You can do it in Excel, you can do it in deleting those customers, the rest of them, the missing labeled customers in Excel, or you can do it in RapidMiner. Since I didn't show you before how you can do it in RapidMiner, so let us take advantage of this special case scenario and do it in RapidMiner. So let me first save my data in new location. Okay, I'm gonna create a new folder here, and this is for assignment decision tree. Okay, and this one I'm gonna add the first one. I'm gonna remove those extra parentheses that usually Microsoft adds when you have the same name of the data. Okay, I'm gonna save that one. I'm gonna close it now. And also from your Blackboard, you're gonna download a new customers that also took loan from the bank, but they are still paying, and we are afraid that they might default soon. So we wanna score their attributes on the model that we created from historical customers. So I'm gonna open it again in Excel. And as you can see, we have the same exact attributes provided in this data. And of course, we don't have the label, and that's our job, to create the label for this data. Let us at least know how many customers we have. So it's not that big data. It's about 34. So remember the header one. So you have 34 new customers who took loan, and we just observed their attributes over 1 year. And now we want to know, and we want to assess those customers, so we don't keep we will inform them if we feel like highly likely they're going to default. We have to make a decision, and we have to really be aware of their situation. Okay, so I'm going to save it to the same location. Okay, and it's not a copy, just predict default. Perfect, and we're gonna save it. And now we are going to start to work with our data. So open Rapid and from there we're gonna bring those two data sets. The first one, the one we're gonna create our model on. Make sure that everything is okay, and that's it. Yeah, I had it before, it's okay. So this is our data. As usual, we look at the statistics, and as I mentioned before, we have missing data on the default status, and that's a problematic. Now looking at other variables, if they are missing, there's nothing. So those are the only this is the only problem that we have in this data that we have really to fix. It's good habit, as we said always, to look at the distribution of all these attributes. And in general, rule of thumb in financial type of attributes, always you're gonna have a skewed data. One example would be average payment of employer in USA. Always you're gonna have a long tail where some wealthy people are getting paid millions, and where the average would be about 50,000 or 40,000. That the average payment or the mean of our population in US as salary. So usually in that situations you might have to either to remove the outliers, in this case the big values. In our data here, since we are not working on creating a statistical model to define the means of our average mean of our population, we don't have to really go and look into each of those attributes in the time being. Other cases you might have to do that. Okay, so we brought the first data. Let me bring the other data as well. Let's predict default, and okay, and look again at the statistics. We don't have missing data here, and again they should match, like the same number of attributes. So here we have about 19 attributes, where the previous one has a 20, exactly 19 plus the label that already exists in this data. Okay, so let me close those. And now let's go to the design. So this is the predict default. I'm gonna leave it here, and now we're gonna bring the risk data. Okay, that's the one. Make sure we link them outside to the result, so the output to the results, and let us run now. Just make sure that this is exact data. So this is the one about 34, and this is the one that has about okay, so this is the one about 424 customers with the missing data. Okay, so let us see how now I'm going to disable the retrieved model for a couple of minutes. We don't need it in the time being, we just brought it. So we're going to filter examples that have missing data. And you do this by using the filter operator from here under the utility. Files, annotations, process control. So I will go ahead and just write filter examples, okay, or something to know that we have removed duplicates. It's really handy when you have duplicate of the same data. Okay, so I'm gonna bring the remove filter examples, and from here if the default I want to only keep the one that are not missing. So that's why if the default is doesn't equal to, or let's see where there's an easier way. It says it's not missing. Okay, if it's not missing, that's the one I'm gonna keep in my data. Clear? So let us click that and let us run and see the output. Okay, now we have, as you can see from here, less data. We have 39, the same number we saw in the Excel file. And also if you look at the stat, now we don't have any missing data. So we get rid of the 34 cases that we didn't have the label in them. Now we're gonna create a model. We're gonna set the role first to tell RapidMiner what is our why, what we are predicting. We are not predicting long-term finance of working. We are not predicting liability to equity. We are not predicting long-term debt to asset. We are predicting the default. So we want to create a why model that has all the other attributes in it. So we're gonna bring the set role to the model, and from here we're gonna tell RapidMiner our y, which is called the label, is the default. Okay, so if you run it again, you will see now all the difference RapidMiner made to this data that gave me a color for the default as a green, just like it distinguish it from the rest. That's all it means. And if you look at the number of attributes down here, we have 19 attributes, which is all the ones that are not green, and the one became a special attribute because we converted from regular attribute to a label attribute, and it's called now special attribute. Okay, so let us bring decision tree, the regular one, and we have multiple type of decision trees, as we say. So you might consider using the others. As I said, there are thousands of operators in RapidMiner. I'm not going to cover all of them, but at least I'm covering the more known operators or algorithms in data mining. So this is our model. So let us first save the old project. I'm gonna click on the location I have my data in. I'm gonna store process here, and I will say default. You can name it, predict default, whatever you want. Okay, let us run, and you're gonna get a decision tree. And what this decision tree is telling you that the following. Okay, move all this around. Okay, and it's your job to explain it more in details, but here's what we can summarize this decision tree as following. The most important attribute from these data that we generated, like from the ones we brought here, that really can explain the decision tree model or explain the why based on the access attribute. So the X that was picked that can really has the highest value to create a tree from is the expense to revenue ratio. And you can see that if it was bigger than to 0.917, and you can guess that if the expense is bigger than the revenue ratio of that company, so highly likely they are not doing well. Okay, they are spending more money on their operation than selling or than having profit in their company. So if that ratio is bigger than 91%, 91.7%, yes, this company is going to default. Now, how many from this data that we brought is going to default, and that goes into this branch? So how many of those that immediately the model was able to say? So we have 77, as you can see, number of items. 77 of those customers that we are trying to look at their situation, this attribute can really filter them out immediately and tell you that those people are going to default. Okay, and they're already defaulted. This is the actual model that we have the label, but this is how the model gonna be explained and then will be utilized for you on a new data that doesn't have a label. Now the second one, if they are still able to have an expense that is less than 91.7%. So then the second attribute now become value, its value importance, called net profit margin. So if it was bigger than 0.201, which is bigger than 20%, so also that's an indicator that they gonna default. What else? So let me continue on the list because this is what we care the most about. Now, if it was the net profit less than 0.21, so the other attributes start to be important to decide if they're going to default or not, is liability to equity. And also it makes sense. So if that value is bigger than 0.329, which is 32.9%, if it's bigger, and okay, here we have the same attribute twice. So let me jump to this value. So ignore this. So if a customer, his expense to revenue ratio is less than 91.7%, and his net profit is less than 0.201, which is less than 20%, less than or equal to 20%, and his liability equity, I'm going to jump immediately here, and his liability equity is less than or equal 37.3, that person also is going to default. So explaining this tree, you have the nodes at the end that are the end of the tree, and you have those branches. So the one you care about in our case here is this yes, and this yes, and this yes over here. Okay, and those are the threshold that if met will identify that this is the situation. Okay, now we have a very small percentage over here for defaulting. As you can see, you have, okay, we have about, if you can see the number again, if you hover on it, yeah, so you have 13 customers here that also this model detected them that they gonna default as well. Okay, it's like this node has both. Majority, the blue one, that they are not gonna default in this branch, but we have some quite small percentage that it might default. Okay, so this is not it has both, but because most of them they did not default, so the label came as no. Okay, that's why we will need other type of models sometimes to explain deeper the analysis here. Okay, so we have the model now. All you have to do now, you're gonna bring this data, the new data, and we saw this data, so let me show it to you again. So this is the stat of this data. We have about we have about 34 new customers to clone, and we have their information over here. No missing data. We want to create the label for this data. So here is your time now to use this model to apply the model to this data and to give me the output results of this data. And not only that, so let us go back a little bit to Blackboard to download the step-by-step assignment, the guideline. So after you work on your own and apply your model, you will have to compare a couple of additional models. Okay, so make sure to follow the directions in this assignment. If Blackboard is gonna open it, hopefully. Come on, there we go. Okay, so you are going to use a decision tree. However, not only that, you will need to generate 5 different decision tree models. Now, if some of them did not work, it's okay, ignore it. I heard that some of those algorithms, the RapidMiner is updating them. Specifically, the least square is currently not working. So try as much as you could to generate additional decision tree models and compare them. So create like 5 tables for me, and in each one you're gonna list how much each model predicted to default with their confidence level. So compare those results. And at the end, consider yourself that you are hired as a business analyst by this bank, and you were asked to tell the CEO, based on this model that you created, who are highly likely among those customers, the 34, they're gonna default. So you might pick the top 5 or top 10 and list them based on each model, and make sure to compare between them, and then decide which one is the best one you are confident with, that really convinced you that the model is the best. We're going to learn at the end of the semester how we evaluate those models and how there is a measurement to pick that will accordingly decide this is the best model. But time being, based on you looking at the model and with the results coming out, just pick one that you think is the best, and you tell me why you picked it is the best, and list out the customer's IDs that those are highly likely to default. Now, the thing I want to mention here, you are going to change those criteria so you create your model, and then based on this criteria here, so let me bring one. Okay, let me just make more sense to explain what I'm saying here. Here's your model, and as we said, you get the model into the model, and then the new data that doesn't have label, we're gonna bring them here. It's gonna label them, and we're gonna create a model. So in the time being, your decision tree has a gain ratio as a criteria of deciding which attribute is gonna start the decision tree with based on that attribute, and then what else? Your confidence level here. I'm not gonna make changes. You can play with those to get a better model, but that's the time being, that's all I'm asking you to do. So this is the first tree that you can see here that the model created for you. from this area here, okay, this is now the model was able to predict what's gonna happen to those 34 customers. I'm gonna arrange them by sort them by yes, because those are the one we are afraid that they're gonna default. Okay, so the model told us customer 20, 21, etc. Those are the one that they gonna default. Okay, those on top. So you might pick, write down or take a screenshot about those, and the one you might decide the cutting value for your confidence level, and see here all of them are the same, so we don't have cutting value actually, so they are all produce the same number. So anyhow, so consider the top 5, and here you don't have top 5 because all of them have the same confidence, so you're gonna pick all of them. So all these are the one that the model said is gonna default. Now repeat this with different information gain, for example. Now also something else you can play with is this value here. So most of the people, and you have the recommendation that comes from the internet. So let us repeat, as I said, this is dynamic, so you can get recommendations all the time. So let us pick what they said here. Let's have the confidence level 0.4. Like I want only the result that shows 0.4% and up. Now, okay, so this is for the yes. Confidence level was yes. Okay, only the yes. Okay, it didn't matter for this specific case, but we're gonna see it matters in other cases. Now what else? Let's see the accuracy level. So the accuracy level brought different data. I want you to explain here. All of them are starting with expense to revenue ratio, but as you can see now, we have different attribute. Here we have the gross profit margin is becoming more important to decide, and you're gonna tell me those who had a gross profit margin less than 60.7%, also the model said they're gonna default. So let us see the data now. It's generated. You might look at the stat and see from here. Okay, we have that the one that they're gonna be with the visualization here. So those are 16 they're gonna default, which make it easier for us to look at the data this way. Now you can look at the confidence level and compare it to the previous one. So the first criterion gave me, see here I have now different values. For example, for sure this model told me number 19 with confidence 100% is gonna default. So this model really assured me that that person is the highest risk. For if you want to meet the CEO, it's gonna tell him yes, first person you're gonna contact is the business with ID number 19, and you know you have to consider some of the aspects. Now compare also the one generated by this criteria or the other one, and which one you feel more confident in it. So this is the accuracy. You can continue. I heard from some of you that the least square didn't work for some reason, so let me apply and see if I'm having the same problem. Okay, yeah, as I said, there's an issue now with the least square. They're RapidMiner, they are updating some of those, so we'll see. So you ignore the one that is not working. However, you might decide, let's say the accuracy here, you might decide to make some changes here in the minimum gain, the number of pre-pruning, number of splitting in leaves, minimum leaf size. So I might decide leaf size to be 5. So let's see if that would change the value of the attributes. Okay, the one was yes. Okay, so we lost now the 1%, and you are getting a variety of values. You see, we didn't see that in the previous scenario. We have here confidence 62.5%. So all I want you to do is to repeat those based on your observation of the the decision tree, which one that you feel that they made the more sense to you. I would not like to have a node that has two categories, like this one was considered yes. Let me hover and wait for it. Yeah, only 5 cases yes and 3 no, only because 5 is bigger than 3. This branch is considered yes, gonna default. So try to find by try and error. This is always the way it is in data science, Duvain, that you will have to spend a lot of time try and error to adjust those values over here until you find a model that you are more confident with to obtain or to adopt. So that's it for now. I hope that clarified some of the issues that you have seen in the original video. Okay.